We'll see. All right, so what I promised is that you guys know how to graph. You can find the intersection when you graph. You guys can use your tables. But where we're at right now is how do you continue to use the algebra method? Now, we know equal value, but there's also another way to do this. So, on Monday, we talked to you guys about equal value method. And we're going to use that same method called equal value to solve this system. Okay, now notice what this system looks like. I'm going to do this in yellow. This is the system. We have y equals negative x minus 7, and then we have 5y plus 3 equals negative 13. And we need to figure out where those two connect. Okay, so here we go. There's a problem. Well, on this side now, you're going to see me write a whole bunch on this because it's going to take a lot of space. So give yourself some space. That equation is in y equals mx plus b form, but is the second equation in y equals mx plus b form? No, it's not. That's a problem because when you use equal value, both equations have to be in y equals mx plus b form. So that's 5y plus 3x equals negative 13. Okay, now we did this at a very small amount in the end of chapter 3. I need to make that look like y equals mx plus b. So how do I do that? What's my first step? I got to get y completely by itself. Yeah, Tatanga. Fabulous, very good. You're going to subtract 3x. Now, if you were here the day before Thanksgiving, this is what we were working on. We did that game. Okay, this is what we had done. Okay. So what's left? Well, I have a 5y. I can't combine these because 3x and negative 13 are totally different. Those are different tiles. Okay. All right. So right now I have 5y equals, all I did was move that 3x to the other side by changing its sign. But I don't want what 5y is. I want what y is. So what do I have to do with that 5? We were close. Yes? Yeah, good. Divide. So we have to divide. Now be careful. You have to divide everything by 5. Ugh. Look at that. That is an ugly looking fraction. But that's what it is. So what we have to do now is we now are ready to do equal value. The only way you can do the equal value method is if both equations say y equals. Okay? All right, so I'm going to come over here because I'm finally ready to do this. So I get negative x minus 7 equals negative 3x over 5 minus 13 over 5. Okay? Oh, again, what a mess. I now have to solve for x. Okay? Well, I have fractions with 5 in it, so I'm going to multiply by 5. Multiply everything by 5. Okay, I want you guys to take it from there. What would you get if you solve for x? You should get minus 5x minus 35 equals negative 3x minus 13. So solve for x. I'll write it out. Okay, you should be getting x equals negative 11. Once you have your x, see if you can go back and find your y. Okay, what would your y be? Good. You get to pick any equation to find y. Which one would be the best equation to find your y? Yeah, I agree, Sage. I would definitely put it into that first one. Ugh. All right. Now I'm going to put this in the middle here, just so we can see it. You have the choice to find y. Please be easy on yourself. Don't make it harder than it has to be. Okay? Put it into the first one. I need y equals a negative x minus 7. Be careful, that's a negative and a negative. So you get y equals negative and a negative is positive. So you should end up with 4. Holy cow. So your answer is 11.4. Okay. All right, guys. How many of you enjoyed that process? How many of you are like, I can't wait to do that again? That was exciting. Did you enjoy it?
Yeah.
I could do this. I mean, it's algebra. I like algebra. I can do algebra a lot. So this is okay for me. But that is a lot of work. This is a mess. While algebra can be long, I mean, when you guys get to Algebra 3, I often have 1 page on a test for one problem because it takes the whole page to solve it. But this is not efficient. If there's an easier way to do it, let's do it, guys, okay? So what I want you guys to think about is, why would we make you do this, okay? Of course, I'm going to show you the hard way first. But I want you guys to think about what comes next here. Avoid that mess. What was the thing that made it hard? What was the thing that we had to do first before we could use equal value? What do we have to do on the left? What was the problem with this problem? There's a problem, okay? What was the second equation? Was it in a nice form? No, it wasn't. So what happens here is we had one equation That's the problem. One of the equations was not in y equals mx plus b. So then we had to do this entire rest of this work. We had to do a whole lot more work just to get it in a form that we could use. So, is there an easier way? What do you guys think? Do you think there's going to be an easier way to do a problem like this? Let's hope so. Yes! That is a yes. If there was not an easier way, I would just be making you guys practice that. But there is an easier way. And so this new method is called the substitution method. Okay, that's what it's known as, the substitution method. Now, before, you don't have to write this next part down. I just want you guys to see that you know how to do the substitution method. We're just going to take it up a notch, okay? If I give you y equals 3x plus 5, and I ask you for this, what is y when x equals negative 5? What are you going to do with that negative 5? What do you do with that negative 5? Yeah, wherever you see an x, guess what happens? Oh, it gets substituted in. What happens if I ask you for x equals 3/4? That's not nice, but you can plug it in. What happens if I ask you to plug in anything? Can I plug in anything? What happens if I say x equals smiley face? Sure. We don't know what that is, but we can substitute it in. You can substitute anything you want in for a variable, okay? And here's where substitution gets a little tricky. It's not hard. You just have to kind of open your mind to, like, I'm not just substituting in a number anymore. I'm substituting in a whole equation. Okay, So in that space below, here's what I want you to write, okay? We now know we had y equals negative x minus 7, okay? That's what we were given. Our second equation was this. 5y plus 3x equals negative 13. Well, guess what I'm going to do? What am I going to plug in? Well, I know that y equals this negative x minus 7. So guess what I get to do? Wherever I see a y, I get to substitute that whole equation in for y. Now notice, we are not substituting in just one number. We're substituting a whole equation into another equation. So here's what it looks like. We have 5 times y plus 3x equals negative 13. Well, what goes here? Well, that's it. All I did was I took an entire equation and put it inside another one. That's it. Now notice, what happens to our y's? Do you see any y's left? No, there's no more y's left, they're just x's. Okay, so now let's solve this guy. We're going to distribute the 5. We get negative 5x minus 35 plus 3x equals negative 13. Now I want you to look at that. That's exactly what we had before. But in how many steps? In 2 steps, we're already where we already know the answer to this, guys. I'll kind of do this quickly, but you guys already know this. When you put all of the x's together and all the numbers together, that's what you get. You get a negative 2x equals 22. Okay? I'm not going to have you work all of this out. You know what the answer is. I just want to show you. In literally 1-2 steps, we're already at the next piece. Okay? So if we divide by 2, yep, we still get x equals negative 11, so on and so forth. Okay? All right. This is called substitution method, and it can get a little bit clear, but you guys got it. Okay, let's practice a few of these. All right, let's practice these 2. I think I'm going to make these a little bit larger. Okay, so you get to a problem like this. First thing you notice, oh, they're not all in y equals mx plus b form. Don't use equal value. It's not efficient, and it's going to cause you a lot more headache. But what do you notice? Oh, I notice right here that y equals 3x. So wherever I see a y, in goes 3x. I will do that always. I will circle it, and I'll draw an arrow to where I'm doing the substitution. So right here, we're going to do 2 times y minus 5x equals 4. Notice all I've done is substitute in 3x for y. I just said, oh, y equals 3x, wherever I see it, there we go. Okay, let's solve for this guy. We get 6x minus 5x equals 4. Oh, x equals 4. How handy. All right, go back and solve for y. Don't forget, you always have to have y in there. Okay, find your y. Remember, I will be looking for on the final your answer as a coordinate point. It's 412. Okay? All right, I want you guys to look at the next one, part B. Think about what you're substituting in. Don't panic if it looks weird. Of course they're going to write it weird. We know that y equals x minus 4. So in goes, wherever that y is, in goes x minus 4. So So you get negative 5 times y plus 8x equals 29. Now remember, when you do the substitution method, all of your, well, in this case, in these examples, all of your y's should go away. You should be left with just an x. That's what makes you able to solve it. Okay, see if you can find x and see if you can find y for b. Okay, so you can solve that. Yeah, see if you can do it. Okay. Now you're going to see where I have this thing that says check your work. You can always plug it back in and see what you get. Okay. Very nice. I think we all got it. Pretty good. Okay, for this one you should be getting x equals 3, y equals -1, so your coordinate point is 3, -1. All right, you guys have done a good job on this one, but what happens when things get just a little bit more, well, they're not harder, you just have to realize what you're substituting in and for where. Okay, so let's look at these next two. Let's look at C and D. Well, does it matter that we don't have an X or a Y, guys? Okay, or does it matter that this one says X equals? You just have to know what you're substituting in. So let's take a look at C, and then I'll have you practice it. Okay, this guy right here says X equals 3 minus Y. So now I'm looking at wherever I see an X, X really equals 3 minus Y. It doesn't matter if you substitute in for X or Y, you just have to know which one you're looking at, okay? All right, so let's substitute that one in. Again, you should have no X's on this one. You should have only the letter Y. All right, I want you to try this one, and once you finish this one, I want you to try D, okay? Oh man, something weird happens. I agree, something weird happens with this one. So I see a lot of you got to this point, and then what happens? Now what happens on this guy? The y's cancel out, because this goes to 0, -2 plus 2 is 0, and you're left with 6 equal to 18? Can't. So how, that's not wrong. You guys did this correctly, but how do you interpret it now? No solution. Okay, now I want you guys to think about what no solution means. Remember, you now have two lines. We're going to draw our two lines. If it has no solution, it means that those lines never intersect. So what kind of lines never intersect?
Parallel.
Parallel. That means this guy right here, it looks something like this. Those two lines look like that. That's what it means to be no solution. It means that those lines will never, ever intersect. Okay? All right. Try D on your own. Don't be afraid of C's and B's. All you're doing is, oh, I see that C equals -b minus 11. Just substitute it in. See what you get. I'll come around and check here. right, when you finish D, let me know, and I will come check it. This all part will come check. So it should be B is -3, and C is 8. So it's -3, 8. It'll be -8. Yeah. This one works out nice. Should get some nice numbers. Okay, very nice. All right. What do you think about substitution? Would you go back and do it the hard way, or would you use substitution as substitution? Okay, nice. Me too, Jacob. I would use substitution as well. Okay, so what are you getting? You're getting. Let's see. So you get a negative. Be careful. That's a -3b minus 33. So it's not -6. It's -3.
Oh.
Okay, that will make all the difference. Alright, so let's take a look. So we get -3. That's going to be a +6. And a 6 is B. So, that's a 6 right here. I know, that's a little unfair, isn't it? Yeah, you've got it. Very good. Alright, guys. You're not doing anything. You got it, because you should get 3. But you should get a -3. Let's just take a look. Okay, so you got 9. There's your 6. You get your 9. Okay. So you should get, oh, right here, that's an 11. So you got it right for what you did. Fabulous. Okay, so how do we do on this guy? So you did, yep, -33 plus 27. Be careful, that's a 6B. Oh. I know, that's a little unfair, isn't it? 6's and B's look the same. All right. So people biology, you should end up with like -27 equals 9B at the end. Okay? Yeah, you got it. And when you plug it back in, you'll get -8, so be careful here. See how it's a negative out front? Don't drop the negative out front. It's a negative times a negative. Okay, so let's take a look here. So you get -3, yes. So what's -33 plus 6? That'll be your 27. So now, yep, you're right, add your 3D over, you were absolutely right. I'm gonna erase that. All right, guys, very nicely done. You get -3, -8. Now you guys can check your work, plug it back into both of them, and it should work. I had to do it before. I will figure it out. Okay, we are not going to, there you go. We're not going to be able to finish all of this, but there's one problem, and that's just the last one that I want us to focus on. And that is this guy. Happy birthday, okay? When you do your review previews, you're going to see all kinds of these story problems. You have to learn how to handle them. Okay, they are tricky and they're not easy. So the more you practice them, the better off you will be. Okay, and this one is set up to give you some hints. I will always help you like this. We'll give you these hints. So you give your friend a bag of marbles for their birthday. Here are some clues to what is in the bag. The bag has twice as many green marbles as red. The bag contains a total of 84 marbles, okay? They're asking how many green marbles are there. And we know that it's not stated, but I'll tell you, there's only going to be green and red. Okay, so let's take a look at how do we do this. What do you want X to be? Do you want X to be red or green? Doesn't matter. We can call it red or green, okay? So let's let X be the number of green marbles. It will help you to write this part out. If you marbles, and we'll let y equal the number of red marbles. It just helps you think about, okay, what's x and what is y. If you want to use green and or G and R, you can do that as well. Okay? Okay. I'm going to try to bring this down a little. How am I going to write an equation for the first clue? The bag has twice as many green as red. What does it mean to be twice as many? What do you do? If you have twice as many, okay, pennies, what are you doing? Or twice as many candy bars. What do you do when you take twice as many? Multiply by 2. So here's what you have to do. The bag has twice as many greens as red. So we let x equal our greens, okay? So we know that green is our x. So we're going to say green is twice as many reds. That's all. That's all I'm doing. Green is twice as many reds. So if I had 5 reds, I would have 10 greens, okay? That's what that means. The bag contains a total of 84 marbles. What are you doing when you total something? Yeah, you're adding. It's add, subtract, multiply, divide. You're adding. So I don't know how many there are, but there's x green, there's y red, and together there's 84 of them. All right, look at what you just created. You just created a system of equations. Now, you could go back and do equal value, or you could do what we just did today. Use substitution. Here you go. There's 2y. Substitute it in. There you go. See if you can figure out how many green marbles there is. Okay. You're going to run across a lot of these in your review previews. Please practice them. It will pay off. Oh, I did that wrong. You guys didn't even stop me. You have to substitute that in for x. I don't know how many it is. Hopefully it is a nice answer. Oh, look at that. It is. So we now have how many red marbles there are, how many green ones are there. Remember, you're going to double that, okay? Yes. So one of the hardest parts about Chapter 4 is figuring out these word problems. My hint to you is always let x equal something and y equal something. We'll only give you one that has 2. Then you read the words, and I always put, okay, twice as many. I try to put it into, okay, and sometimes it helps if I do green is twice as many reds. I can write it out with words there if it helps. But take the words and try to put them into a mathematical sentence. The word total always means you're going to add something together. You're always going to add your x and y. Now on on Monday of next week, you guys are going to see yet another method. So between now and Monday, really practice 411. There are all kinds, and 421. There's all kinds of these things to practice. Now these notes are for you to help you. On the back are some more challenges. I recommend trying some of those challenges to help you with this. But this is all built for you guys to keep practicing it. Keep doing them. They'll get easier the more you do them.